Good day, everyone. Now, before you start thinking, oh no, another boring talk about data, let me tell you something exciting. Data is not just numbers, it's the key to understanding the world around us. In fact, data science is the art and science of transforming raw data into valuable insights that drive smarter decisions. It helps us predict the future, optimize operations, and sometimes even discover things we never knew we needed to know. Imagine trying to make an important business decision without data. It's like trying to navigate through a city with no map, no GPS, and no idea where you're going. It sounds stressful, right? The different types of data we'll talk about today will help you understand how we organize, analyze, and draw conclusions from the vast oceans of information we have at our disposal. So, buckle up, because this is going to be a ride through the data-driven universe. Let's start by breaking down the categories of data. You have your structured data, unstructured data, and semi-structured data. Imagine a messy room. Structured data is like that perfectly organized desk. Unstructured is like a room filled with random papers scattered everywhere, and semi-structured is somewhere in between. It's a closet that kind of makes sense, but you still trip over shoes. And of course, metadata is like the label on a file folder that tells you what's inside, making your life a lot easier. All right, let's focus first on structured data, the gold standard of data. This is the data that makes everything simple. Structured data is highly organized, typically in tables made up of rows and columns, just like a spreadsheet or a database. You can easily find and retrieve it using SQL or other query languages. So it's like having your entire life organized in color-coded folders. Structured data is predictable, reliable, and easy to manage, much like that friend who always arrives on time and never forgets your birthday. Examples of structured data include things like financial records, think transaction data, account balances, and sales figures. You can also find it in inventory systems, like product IDs, stock levels, and pricing information. Basically, anytime you open up Excel or a relational database, you're dealing with structured data. Now, let's turn our attention to unstructured data, the rebellious, untamed sibling in the data family. If structured data is like your organized closet, unstructured data is like your closet after a shopping spree, clothes, shoes, and accessories everywhere, with no rhyme or reason. Unstructured data doesn't follow any specific format or structure, so it can be much harder to analyze. It's raw and chaotic, but that's where the magic happens. You need specialized tools like natural language processing, NLP, for text analysis, or image recognition algorithms for visual data, to start making sense of it. Think of unstructured data as things like emails, customer reviews, or social media posts. There's no obvious organization, but when you process it, you uncover insights like sentiment, opinions, or even trends. You can also find unstructured data in multimedia formats, such as audio, video, and images, whether it's a YouTube video, a podcast episode, or a snapshot from a wedding. Now, let's talk about semi-structured data, the hybrid that's somewhere between structured and unstructured. It's like a well-organized garage. Things are in their general places, but you still trip over the occasional misplaced tool. Semi-structured data has some inherent structure, like key-value pairs or tags, but it doesn't strictly adhere to a rigid schema. This type of data is common in modern web applications, IoT, Internet of Things, devices, and big data analytics. It's flexible, and that's why it's so popular. You see semi-structured data everywhere, from XML files used in data exchange on the web to JSON data used in APIs, or even log files that contain timestamps and error messages. While semi-structured data isn't as easy to work with as structured data, it's much more manageable than unstructured data, and it's increasingly important in today's data-driven world. Now, we can't forget about metadata, the unsung hero of data management. Metadata is basically data about data. It describes the structure, content, or context of your data, making it easier to find, interpret, and manage. It's like the label on a file folder that tells you what's inside, without having to open it up and dig through it. For instance, file metadata might tell you when a file was created, what type of file it is, and how big it is. In a database, metadata describes the tables, columns, and relationships. And if you look at image metadata, often stored in EXIF format, you might find details about the camera settings, location, and date the picture was taken. Without metadata, we'd be wandering through an ocean of data without a compass. Data can also be categorized by its nature, and here we have two main types: quantitative data and qualitative data. Quantitative data is all about numbers and measurements. It's the math nerd of the data world. Think of it as the data that answers the how much or how many questions. Qualitative data, on the other hand, is more descriptive. It answers the what or why questions, giving context to the numbers. If quantitative data is a calculator, qualitative data is a storyteller. They work together to paint a complete picture. Let's dive deeper into quantitative data. This type of data is all about numbers you can measure, count, or calculate. It's divided into two subtypes: continuous and discrete data. Continuous data is like trying to measure something that can take an infinite number of values within a range. For example, when measuring height, there are infinite possibilities: 180.5 centimeters, 180.6 centimeters, 180.7 centimeters. You get the idea. It's like a never-ending road that keeps going, and you can stop at any point. On the other hand, discrete data deals with countable numbers. These are whole numbers with no decimals. For instance, the number of cars in a parking lot or the number of students in a classroom. You can't have 3.5 students, right? Discrete data is straightforward and clear-cut, no fractions allowed. Let's switch gears to qualitative data. Unlike quantitative data, qualitative data is not about numbers. It's about categories and characteristics. This is where the nominal and ordinal types of data come into play. Nominal data is like sorting things into different bins with no particular order. For example, sorting animals into categories like dogs, cats, and birds. There's no hierarchy here. Each category is just different from the others. It's like choosing your favorite ice cream flavor. You like chocolate, I like vanilla, but neither is better than the other. On the other hand, ordinal data involves categories that have a specific order or ranking. It's like ranking your favorite ice cream flavors from best to worst. You know chocolate is your favorite, but the gap between your second and third favorite is not mathematically defined. It's more about relative importance or preference. Next, we have time series data. This is data collected in a sequence over time, often used to detect trends or patterns. Time series data is great for forecasting and understanding the trajectory of a given phenomenon. For example, you can track stock prices over time or the temperature on a given day. It's like watching a movie in slow motion. You get to see how the story unfolds and understand the highs and lows over time. Spatial data is the data tied to geographic locations, whether it's GPS coordinates or environmental data. It's like trying to find the perfect location for a vacation. Latitude and longitude are your best friends here. With spatial data, you can map things, visualize them, and even analyze geographic patterns. It's the where of data. For instance, you could analyze air quality at different geographic locations, or figure out the optimal locations for new stores based on demographic data. And finally, let's talk about big data. Big data is like trying to drink from a fire hose. There's so much of it, and it comes at you fast. But don't worry, with the right tools, we can handle it. Big data refers to data sets that are too large and complex for traditional data processing methods. We're talking terabits or petabytes of data, and it comes in all shapes and sizes, structured, unstructured, and semi-structured. It's generated at an incredible speed, from social media posts to sensor data from smart devices. But with the right technology, big data can be used to uncover trends, make predictions, and even change industries. To sum it all up, data comes in all forms: structured, unstructured, semi-structured, and metadata. And when you break it down by nature, you get quantitative, continuous and discrete, and qualitative, nominal and ordinal. Plus, there's time series and spatial data for special cases. Each type of data has its own set of rules and tools, and knowing how to handle each one is crucial for effective analysis. Understanding the different types of data is the foundation of data science. It's like knowing which tool to use before you start a DIY project. You wouldn't use a hammer to screw in a nail, right? Similarly, knowing what type of data you're working with will guide you to the right methods and techniques for analysis. Whether you're working with numbers, text, or locations, it all comes down to understanding the data and what it's telling you.